Alright, so last time you guys watched a video on atomic structure, we're going to take that one step further. We're going to take some notes as to how we actually count protons, neutrons, electrons. There's 3 rules that we'll use, and they're actually on this sheet here. Okay, so you guys picked up this packet last time we met. If you don't have it, it is on Blackboard, so go ahead and download it if you're missing it. But basically, we're just going to go over the 3 rules of atomic structure. Okay, very simply put, first off, we're going to need a periodic table. Okay, and from that periodic table, we're going to be drawing information to figure out how many protons there are, how many neutrons there might be, and how many electrons there also are. So that said, first things first, okay, atomic number is always equal to the number of protons in the nucleus. Okay, so example I can give you guys is xenon, Xe. Okay, I'm going to go here to my periodic table, and I'm going to go ahead and look, and I'm going to see that xenon, Xe, is number 54. That tells me that there are 54 protons, okay, in the nucleus of xenon. Now, the second rule that we're going to say, the number of protons in the nucleus, that's going to be equal to the number of electrons. Okay, for our purposes. By the way, the symbol for that is E negative. The symbol for protons is P positive. Okay, because protons are positive, electrons are negative. So the number of electrons buzzing around the circle for our purposes are always going to equal the protons because we deal with neutral charge. So 54 protons means 54 electrons as well. Now the last rule, mass of an atom or mass number of an atom is equal to the number of blank plus the number of blank. Well, you guys should know this based off of what we just talked about. We talked about the nucleus of your atom containing all of the atomic mass, or all of that mass number. So protons and neutrons, which reside in the nucleus, will also result in the mass number. So the number of protons, P positive, and neutrons, and not. Okay, those two added up are going to be our mass number. Now, you guys are looking at this and you're going to probably say, well, you know, yeah, okay, protons easy, electrons easy, but there's nothing that solves for neutrons. Let's go ahead and use algebra real quick. If I subtracted protons from both sides, you could come up with this equation, okay, that would say that neutrons, okay, and not, would be equal to the mass number minus our protons. Okay, now that might be helpful for you if you want to just rearrange that. Okay, but again, mass number, which one is that? Well, mass number, simply put, let's go back to xenon. That's our example. Okay, if you look at xenon, Xe, it's 131.30. The mass number for this is actually the rounded value of the mass. So xenon, 131.30, okay, would round down. Anything 5 or less rounds down. I'm sorry, 5 or above rounds up. So this is below 5 means rounds down. So 131.30 will round down to 131. So our mass number is 131. Okay. Based off of rule number 3, to figure out how many neutrons we have, we need to do a little bit of math. We need to take our mass number minus our protons. So 131 minus 54, I believe, is 77 neutrons. Is that right? Yeah, that's right. Okay. Now going back to this average atomic mass. Average atomic mass is going to be that number, but it's going to be the whole number. So it's going to be 131.30. Now, by the way, maybe make a note to yourself that average atomic mass is going to be a decimal. Okay, and your mass number we round. Lastly, to fill out this chart, xenon. Okay, now at this point, you guys should be able to fill out this whole chart. Okay, so when you do so, make sure you fill out this whole top face. And again, I rearranged some things because I wanted you guys to try to get a different look at it from this bottom chart as well. Okay, so go ahead, fill out this whole chart for me. That's your assignment for this first segment.